Welcome to case 3. Case 3 is when m is even, as it was in case 2, but now n is also even. So the first example, you can see you have a square on the sine and a fourth power on the cosine. So they're both even. All right, so what you're going to do is you're going to take every sine squared and make it into 1 minus cosine of 2x over 2. That's one of our double angle formulas. And we're going to take any cosine squared and make it into 1 plus cosine of 2x all over 2. So first of all, let's go ahead and change this up because we need to have a cosine squared. So I'm going to make this a cosine squared that is squared. Now I'm going to go ahead and take sine x out and replace it with 1 minus cosine of 2x over 2. And I'm going to take the cosine squared and replace it with 1 plus cosine of 2x over 2. Don't lose your square. All right, now we need to multiply this all out. Let's pause for a second. Okay, so again, I'm going to square that. Now I need to do my whole foiling process here. So let's pause and you foil as well. All right, when you're all done with all of the foiling process there, the distributing process, you should end up with this integral. And now we are all set to break this up into smaller chunks and get our answer. So let's break this up into smaller integrals. And now we're going to integrate each individual integral. Don't forget to do your chain rule in reverse for that second integral. And now we are back to an even cosine exponent and an even sine exponent. You're probably saying, well, wait a minute, sine's not there, right? Sine doesn't exist there. But that means it's sine to the 0, and 0 is considered to be even. So they're both even exponents. So as we have just talked about, we're going to take this and replace it with 1 plus cosine of 2x. But notice, this is where it gets a little hairy. It's 1 plus cosine 2x, but the angle was 2x. So 2 times 2x is 4x. So let's just focus on this one while we're here. We can then split it up into an integral of a half plus a half cosine of 4x. And the integral of a half is a half x. And the integral of a half cosine of 4x is 1/8 sine x, sine 4x. Because don't forget that you have to divide by the chain rule. And the last integral, this is a really fun problem, that has a even sine and an odd cosine. So you get to do pretty much all cases in this one problem. So we're going to take the cosine cubed and we're going to split it up into cosine times cosine squared. Oops, and these are 2 x's. Sorry about that. Now you can go ahead and take your cosine squared and make it into 1 minus sine squared. Now you can do your u substitution. So this becomes 1 minus u squared times a half du. That means that we get a half u minus u to the third over 6. And you can go ahead and put back your sine of 2x. Okay, look at all that beautiful math right there. We did lots of beautiful math. Now you got to put it all together into one nice, neat little package. Oh, it's so fun. Don't forget that this was a minus right here, and the minus has to be distributed. Don't forget there was a minus here, and that minus needs to be distributed. Oh, such good times. Okay, so we're going to put it all together. I'll give you the final answer. So if I've done all my fraction work right, this should be your final answer. Okay, now go to the next slide. Pause this video, go to the next slide, and you're going to try the next one. And then if you can't get the answer to the next one, come on back to this video and scroll down to 640, and then you can see the solution. And here is the solution to the U-try problem, which you can pause and correct your work if you had any issues.